Welcome to Math 105, where we are working on the compound interest lab today. This lab concerns situations modeled by a compounding process. A typical example is the way interest accumulates in a savings account. The first problem builds a compound interest calculator. You also build a balance sheet to see the effects made for each interest payment. So once we complete this lab, and then our other lab, if we have your simple interest and then annuity lab, you can use these on your test if you prefer, and then again on your final or your homework. So once that we build this, all we have to do is actually go ahead and change some of our values, given that everything that we have for a formula is entered correctly. So first, let's create a title page with the name of your lab, your name, your date, and your course. So I'm going to go ahead and label this as your title page. On your title, compound interest lab. We have your name. We have our date. We have our course, which is Math 105. If you prefer to put your section, that's fine. Then I might choose to center things. Have that all together. Oh, it's because I did it that way. Course 5. Make it look nice, add some creative flair, and let's go to our first problem by opening a new sheet. We'll just say this is problem 1. So it says Fred Jones places $3,000 in a savings account that pays an 8% annual interest rate compounded quarterly. So it gives us this template, which we're going to follow. So we have problem 1. Problem 1. And then let's see, A3, we have the word compound. Cannot use this. Compound interest. We have PV, we have RMT, we have total number of periods, we have your rate per period, we have FB and INT. Now notice that these are being cut off, so we might want to go ahead and expand these either manually or if you double click, it will do it for us. And before I get too far, I want to make sure that I'm in Times New Roman. I like 12 font. There we go. And I'm probably going to put all of these in black and expand. And I might choose to center all of my values. So when it says your PV, so compound interest is just telling us that this is your compound interest problem. So what is our PV amount? Well, it says Fred Jones places $3,000 into a savings account. So we have $3,000. And this is a monetary value. So let's go ahead and put currency on this. It says in a savings account that pays an 8% annual interest rate. So your rate here is 0.08. And it's compounded quarterly. So quarterly is our M. So quarterly means 4. Your time, we don't have a context for time quite yet, but perhaps if we keep reading, it will. So it says, read the following problem above to fill in the given information from your Excel sheet from B4 to B6. So that's what we've done right here for B4 and B6. Then it says in B7, we will be looking at time being 5 years. So that's perfect. So we're going to write the number 5 here. Then it says use the above information to find B9 and B10. Well, B9 gives us formula is equal to B6 times B7. So whether we type that in or we can go ahead and select, we said B6 times B7. So either one of those, whether you type it or write it. So we have the total number of periods. Now this is typically found in your formula where we have your exponent, where we're multiplying your compound periods versus your time. And that's what your total periods is. Now your rate per periods, they already give that to us. That is what we've called and labeled as I. in your formula, that is when you have your rate divided by your compound period. So for us, we're going to hit equals, and we can write either B5 divided by B6, or we can go ahead and do that by clicking on your values here. So your rate divided by your period. So we have 0.2. And it says for B11, look at the back at the formula sheet from chapter 2 to find the formula for future value. So for our future value formula, right, because it's compound interest, we have FV is equal to PV 1 plus our I, or this is really our R over, that's not ideal. Oh, maybe it'll allow me to erase here. There we go. R over M raised to the M times T. So this being your total number of periods here, and this is being the rate per period. So when we go back here, we have equals, we have your PV. So let's go ahead and select your PV amount. And again, we don't want to write your present value amount. I don't want to write 3,000. I just want to select. Then I have 1 plus R over M, that is your rate per period, divided by, not divided by, raised to, so that is this exponent here, and this is your exponent of 20. Now it says reference, and let's see why. Let's see. Oh, because when it pulls up with reference, anytime you have multiplication between the two, we need to put a multiplication symbol between your B4, your present value, and your parentheses. So let's go ahead and hit enter, and that should clear it up. And again, this is a monetary value, so we want to see this dollar amount. Then when it says for B12, look at the back of the formula sheet for chapter 2 to find the formula for compound interest. You may need to look at your notes. So when it comes to compound interest, right, we want to look at how much interest did we earn. Well, the interest that we earn, we're going to take a look at the difference between your future value amount minus your present value amount. So for us, we want to take your future amount and subtract out your amount for your present value. So the interest that we have earned just by allowing it to sit in our bank account over the 5-year periods at a compounding rate of compounding quarterly with a rate of 8%, we should have just earned a little under $1,500. So let's go ahead and look at the text box. So it says, in a text box, answer the following questions using college level sentences. So describe some of these values based on what we have. So let's go ahead and insert the text box. So it's A, what is this account balance after 5 years, and how much interest does he make in each of the 5 years? Let's see if we can answer that. So what is in his account balance after 5 years, and how much interest does he make in each of the 5 years? B, it says, oops, how much is in his account after 9 years? So again, use what you have built already to figure out what we could change to see after 9 years. How much would you make? And C, it says if we change the compounding period in B6 to monthly, how much is in the account after 9 years? So again, if you change now to a compounded period for monthly, how much is in the account after 9 years? Now make your sheet look a little bit more professional by adding a few little details. such as, but are not limited to, monetary values, kind of like we did already here. Making sure it's to decimal places. Having things that are nice and centered as well goes a long way. So I might center everything here. And then I like putting things in bold, making sure nothing is cut off, things like that. Now it says, use a template above to answer the next set of questions and in a new text box. So let's insert a new text box here. And it just tells us you are offered 3 investments. The first promises to earn 14.5% compounded annually. The second will earn 14% compounded quarterly, and the third will earn 13.5% compounded monthly. Which is the best investment and why? Give as much detail as possible to support your answer. Save your sheet, considering title the individual sheet as compound interest. So they're just talking about this one being labeled as problem 1 or the compound interest sheet. So in this new text box, determine part A on here. And I might not want to fully write this whole thing out. But again, when it's just describing the best investment, make sure you say why, as much detail as possible. Again, you're going to be using this template and just changing a couple things, compounded monthly or annually, given a different interest rate. Let's go ahead and look at problem 2. This is problem 2. It says copy the template cells A to B12, A1 to B12 in problem 1 in a new sheet. We will be using this problem to use the goal seek tool learned in lab 1. So that being our simple interest lab. So let's go ahead and copy everything over. Of course, we have a new text box each time. So I'm going to delete that. And if we want, we can perhaps delete this, but let's actually not delete that. That's what the whole reason why we copied it. So it says in A3, label this as goal seek. So first, let's actually change this to problem 2. Oops, not 12, problem 2. So it says A3, we're going to change this as goal seek. It says in a text box in college level sentences, A, determine what interest rate will be needed in order for the future value to grow to exactly 9,765.33 over a 25-year compounding quarterly. So A just says determine at what interest rate will be needed in order for the future value to grow to exactly $9,765.33 over a 25-year period, compounded quarterly. So back in chapter 2, we talked, in lab 1, where it was where we talked about chapter 2.1, we were learning this goal seek tool in problem 2. So in order for our goal seek, we're going to go all the way up to data. And we're going to do what if analysis, and this is the goal seek tool. Now in cell 1, we have some known value that we want to set it to. So set cell, so I'm not going to give this particular one away because we have learned about this tool. So go back to lab 1. So simple interest lab problem 2, how to use goal seek. So again, kind of to walk you through the bare minimum, we're going to set cell 2. So we're going to set whatever our known cell to this cell, whatever our known value is in that cell. So select that cell. Then it says to value. Well, what value do we want specifically? And then by changing what particular cell. So what cell can we go ahead and change and vary? So again, our question is determine at what interest rate will be needed in order for the future value to grow to exactly this amount over a 25-year period. So again, if we want it to be a specific amount, it'll be here. This is the cell that it's going to correlate to. And then we want to change the amount here by varying the value. So again, we're just going to be changing these values. The reason why we copied it is because these values need a specific time, which we can go ahead and set some of these values as well. So we have 25 here, we know as your time. They do tell us that it's quarterly, so we can do that. We don't know exactly that it is 8%. And then we don't have a present value to work with, but that's okay. We just want to know what interest rate will we need in order to grow. So we don't have this. This is our unknown amount. Again, we don't want to fix these, but we have this as our known cell. We want to make this as close to actually exactly this amount. And that doesn't mean we're going to get rid of this. We need this equation here. We just want to know at what interest rate would we have to do so that this is manipulated to have this exact answer. We're going to keep everything else the exact same, and I'm going to put it back right here. Now it says save the sheet, and you might consider putting this one as the goal seek. So if we want, we can write that as problem 2, or we can change it to write goal seek. Oh, I'm so sorry, I missed a question. So B is how much interest did you earn at this percentage rate? So again, we do not know your rate, right? That's something that we would need to use your goal seek for. However, we do know what exactly we want your future value to be. We're going to keep your present value at 3,000. We just need to know what value is this. Now let's go to problem 3. Again, this is kind of an unfinished problem. Our goal, because these are pretty easy questions, our goal is to see, could you determine your goal seek answer? So let's go to problem 3. So it says, in a new sheet, follow the template below. In this sheet, we'll be finding the present value. So let's go ahead and have this new setup. Instead of problem 1, it should say problem 3. So we have PV unknown. Make sure our spelling. Come on. There we go. We have PV unknown. We have PV RMT. We have total number of periods. They say MT. We have rate per period, R divided by M. We have your future value and your INT. So let's go ahead and expand. Let's do some of these finishing touches. So let's do times New Roman. Let's do 12. I'm going to put these items in bold and center. And you'll notice that some of this is text wrap as well. So let's say that we wanted to text wrap some of ours. So notice that if this is being cut off, perhaps I want to do that. What we can do is go ahead and do this. And then we just, where did this text wrap go? There we go. We can just hit this button right here where it wraps it for us. Otherwise, if you'd like, we can just keep it expanded. Now this is PV unknown. This should just be PV. There we go. We also have the word complex interest. We also have simple interest. There we go. One more time, expand it. All right, so now let's go ahead and start reading. It says you want to buy a 15-year bond with a maturity value of $9,000 and you wish to get a return of 5.25% annually. So let's go ahead and fill that material in. So you want to buy a 15-year bond. So we know that your year is going to be 15. Maturity value. So maturity value means your like end value. So what you finish with, right? Us being mature adults, right? We had to grow all the way up to what we are today. So that is going to be our $9,000. And let's put this in a currency amount. And we want a return of 5.25%. So that's our rate, 0.0525. We're talking about annually, so annually being 1. And we want to know what is your PV. So this is an unknown PV. So it says fill out the remainder of the cell given the new information. And keep in mind, it does now tell us your formula. So that actually was here from the back. So if we have this for your future value, that just means for your present value, right? We can take this amount here. So if we have all of this amount, we can go ahead and divide it and put it on the other side, leaving your PV alone. Now, before we get to that, notice that it says R over M, M and T. So that is referring to the total number of periods and your rate per period. So let's go ahead and do that quick numerical value. It says M times T. Well, your M is here times your T value here. And then you have your rate per period right here. We have R divided by M, R divided by M. Now your interest rate, we could also fill out, is your future value minus your present value. Now there's nothing in your present value now, but we're gonna find out what that is. Let's enter your present value in. So we hit equals, and we have your future value, because if we kick this whole thing over, we have future value. So let's go ahead and select your future value. Divided by, now we're gonna divide by this whole thing. 1 plus your rate per period, close your parentheses, raised to, and this is your M times your T, which is this total amount right here. Go ahead and hit enter. And we don't need this whole thing. Instead, let's put it into a currency, and it'll allow us to simplify it out a little bit further. So that should be your present value. So when we start out with, or if we wanted to grow into $9,000, given all of this amount, right, we need to start with $4,177.45. I think there is a slight mistake on this. It should say the equation above does not go into, instead of D4, I think it means B4. So this equation is not going in B4. We needed to, as you see, manipulate it into the equation here. So now it says if FV is equal to PV, 1 plus R times T, then look back at your notes from chapter 2.1 and determine the equation for PV, given that it is a simple interest over the rate, over the 15-year period at the same rate. Note C6, C9, and C10 will be empty. So what it's asking us for is that it now wants us to figure out your simple interest problem, given your rate, your time, and your future value. So we're going to do the same thing. So we can actually go ahead and just copy everything over. And then let's go ahead and start to delete what we don't need. Because it's simple interest, we don't have your compounding, right? We can delete that. We can delete these two, because as it tells us, we do not need anything that suggests we have compounding. So compounding being these 3 values here. So with your simple interest, if we have future value is equal to present value times 1 plus R times T, again, if we're looking for PV to be all alone, let's go ahead and divide this over. So now let's put in over here, your PV amount is equal to your future value divided by 1 plus your R, so go ahead and select your R, times your T, go ahead and select your T. So for your simple interest, right? For simple interest, we have to start with a lot higher amount. I'm going to just change this into a currency because there's no compounding. So notice that with it just sitting into your bank account, that it's going to do a lot more just sitting here, whereas it's not going to be as much in a simple interest account. So make sure you give the context into a text box. So it says, how much will you pay compound interest problem over the future value rate time to achieve your answer? Same thing with your simple interest. So make sure that we just write full sentences given what we have just performed. So A, how much will you pay in the compound interest problem? He says, how much will you pay in the simple interest problem? Give all of the context to the problem as much as you've done, and then just add some of the flair. Make sure you're saving your sheet as you go. So what I mean kind of by some flair is maybe you highlight the boxes that we're supposed to be looking at your final answer, maybe putting everything in the center. Same thing over here. Maybe I want to highlight this amount. Unknown, so that would be your answer over here. These two would perhaps be your answer. And then as far as printing goes, right? A lot of our information is kind of going down. So other than, let me expand this. Other than when you do your page layout and doing narrow margins, you notice that by doing that, it shows us this, the dotted amount or the dotted line. So that's going to tell us our printing area. We can go ahead and make sure that everything is in the right printing area. Push that over. Problem 2, same thing, margins, narrow. I'm going to move everything over. Again, margins, narrow. Move it over. And it's all in. So when we go ahead and hit Control P, when you go to export it or even print it to a PDF, right? Doesn't really matter. We're going to go ahead and print the entire workbook. And in doing so, notice that it'll print out all of my sheets. I want to click through and make sure that everything looks good. If I wanted to print my grid lines, I certainly can. In doing so, I can just hit, let's see, page layout. It should be grid lines, print headings as well. So if you went and did that again, notice that everything now comes up. I'm not a huge fan of it, but some students do like how it looks. So I might not do it for this first page because I like it pretty empty. But you could, if you wanted to, do it again for here. Notice that it kind of comes up. I'm not a huge fan, but it might be, you might need it in the future if you have lots of data and it's kind of hard to keep track of. And there you go. That is your compound interest lab.